We're going to wrap up our discussion on processes in Linux. And in the next lesson, we're going to talk more about daemons and services. For wrapping up processes, we're going to talk about how to monitor and then finally terminating those processes. So let's talk about the top command first. This is a nice little command that'll allow you to get a kind of a good view of what's happening on your system. It gives you a nice tabular format. It'll refresh every 3 seconds or so. Of course, that can all be controlled through different arguments that you can pass to this command. You could also customize which columns you'll have in that tabular view, but by default, it'll show you the process name, the CPU time, the memory percentage, and so forth. So again, it's a good way to take a look at what's happening on your system. The reason it's called top is because it'll show processes that are using the most resources on the top. So you're only going to see the resources that are using a lot of processor time or CPU time or a lot of memory. And again, you can control how it displays with some of the various options for that command, and you'll play with this in your Linux environment. Speaking of tools for viewing your processes, the other one is print snapshot, or the PS command. This is pretty common. If you go into your system and run the PS command, if you're logged in as a standard user, the only processes that you will see are most likely the bash process that you're in and the PS command that you ran, right? Just like you see on this screen. You're not going to see any other processes. The reason for that is it's only going to show you processes that you started, that you own. This is a great command if, prior in the previous lecture, we were talking about foreground versus background processes. If you're running a lot of things in the background, this command will show you all the stuff very quick and easy, all the things that are running in the background in your user space. If you want to see things that are outside your user space, you have to use a switch to do that. And on the next slide, I'm going to show you some of the switches that you can use with this command. So these are some of the switches that you can use. I'll show you an example in the next slide. But continuing with the various switches that you can use, again, you can reference these in the handout or in the textbook. And one more slide of switches. There are a lot of options. The last one you see here, X, is the must have a TTY restriction, so it's going to show you things that are running in an active terminal, for example. So you're not going to see background processes that are running as daemons, as an example. And then we can show, what type of information. This lets you customize what type of information the PS command is showing you when you run the command. And finally, a few more options for the PS command. There's a lot of options for this command. So the state, so the PS command is going to show you the state. So there are a bunch of states you see here, R, S, T, D, W, X, Z, and so forth. So this will show you the state of the process, and you can modify the state of some processes depending on the state. So you can see here some examples of someone who ran the PS command. This is from your textbook. On the upper right, you see just the PS command. So it's showing you things that are running just in that person's account. And then on the lower right, you see it run with the AUX argument. So that's showing us all processes that are running in any terminal session. And then on the bottom left, you see someone ran the PS space F command, right? Passing the F argument. Oh, and by the way, the F argument is useful because it shows you the relationship between the parent and child process. That's why you see those lines on there. There are other commands that can show you that as well. When we look at services, you'll see with services, it shows you a similar view showing you that kind of tree that shows you the parent of a child process. You can set the priority of process in Linux. This is using the nice command usually, which I'll talk a little bit about. But why do we worry about the priority of processes? Because we can have a lot of processes running on a Linux system, right? Really on any computer system. We've talked about multi-threading and multi-user operating systems in a previous lecture. So the PS command and many other commands, you can see the priority of a process and you can control those processes. You can suspend it, kill it, or you can alter its priority. Let's learn a little bit more about altering priority. So the nice command is the command that we use to change the priority of a process, either when we start the process or while the process is running. Why is it called the nice command? You're basically telling the operating system how nice you want the process to be. If we're being very nice, we're going to let other people have their turn, right? If we're not being nice, we're not going to let other people take their turn. We're going to take turns from other people. So a lower nice number means that you're not as nice, which means you're going to use more resources. You're going to hog more memory, for example. And when you're being more nice, that means you're moving yourself out of the priority, right? You're setting your priority lower and letting other people take more resources. By default, normal user accounts logged into Linux usually won't be able to set a negative nice number. Only the root can do that, or you can use the sudo command to do that. Since negative numbers are usually lower, that means we can make our process less nice if we use negative numbers, and we can make them more nice using positive numbers. So here's an example of using the nice command, where we can change the niceness of various commands. You can see the one on the bottom there. So we can see that process 18311, the third from the bottom in that command, we're making it very nice by setting it to 20. We're making the process 53113, which is the next one below that, is a little less nice at -5. And then the next process below that is even more less nice. It's -10. So you would usually modify the niceness by passing either the PID, or you can pass the process image name, as well as the user account for that process. So a process will typically terminate once it's completed whatever task it's doing, or if the user quits the process. For example, if you're running the VI command, you would quit by typing escape:*Q, which you've seen before. If you're in the top command that we talked about earlier in the lecture, you would hit the Q button and it would exit. Same with the more command or the less command, right? Different commands have different ways to exit, but usually there's some elegant way that you can exit from the command. Some process will terminate abnormally. It could be because the user sent a signal that told the process to end abnormally, or because the process crashed, or something happened, right? Usually when a process is terminated, it can do a dump of the memory at the time that it was terminated, which you can use for debugging, but they can get very large. So an orphan process is basically a process whose parent has been terminated. So usually a process in Linux, almost all processes in Linux, have to be started from another process. For example, if you're running a command in your shell, the parent for that command is typically going to be bash. If you run a command from within bash and launch another command, then its parent will be the command from which you launched it, and so forth and so on. So who is the parent for bash? Well, when you logged in, there's a login daemon. That's your parent. And then the parent to that might be init or the system. So you can always follow the lineage of most processes back. Now, what happens when you run a command and the parent of that process stops or is no longer running? Does that mean that all of its children die? Of course not. The children continue to live after the parents die. You can also have zombie process. So that's a process that terminates, but it can't report to its parent who is currently sleeping, right? So whenever a parent process dies or is stopped or what have you, someone else takes on the role of parent for that child process. If that process terminates, but it can't report to the parent because it's currently sleeping, so it's not able to send that signal, then that's how you get zombie processes. So there may be times, for example, when we have a zombie process or a process that's hung or using too much memory, that we want to kill that process. So the kill command is one command we can use to do that. So we can use the kill command to kill misbehaving processes or processes that need to be stopped. When you run the kill command, you have to send it a signal and usually the process ID, or you can alternatively send the process name. But if you send the name of the process, it'll kill all instances with that name. But there are various signals that you can send. I'm going to show you in the next slide a list of some of those signals. So here are the list of signals that we can send to a process when we use the kill command. By default, when you send the kill command, it'll use the sig-hup command, right? So terminal connection lost. But you can send other signals as well, and depending on how you want that process to kill itself, you can send various different types of kill commands. Usually you don't have to pass these different signals, but one thing about these signals is different applications and programs and processes will handle these signals in different ways. So sometimes it might be useful to use a specific signal because you know that the process is going to handle that signal a certain way, and that's, it's going to do something specific when it goes down, when you send it that signal. So there's also the pkill command, and then of course the kill command that I just spoke about, and these are both covered in more detail in your textbook. So if we want to shut down Linux from the command line, we can use systemctl followed by one of the modes that you see here. So you have default, emergency, exit, halt, etc. This is sort of like in the old days when we would use run levels. Run levels are really a deprecated concept in modern versions of Linux. If you are familiar with run levels with the init or system 5, we're going to talk more about system 5 and init, kind of what that was in the next lesson in this module. But for right now, just understand that when you're going to shut down a system, you can use these various modes when you do a shutdown. So for example, you might use emergency if you want to switch to single user, so only root can access and use the system. So it puts it in single user mode, and then you can switch it back to default once you're done doing whatever it is you need to do. You might switch to the mode for power off if you want to turn the server off, for example. So all processes are going to use resources, right? The PCB is the PCB, by the way, it's kind of a fancy way of saying that the image of the process is going to be stored in operating system memory. So you always have to have memory allocated in order for a process to run. It's also going to typically use some CPU time. So part of the kernel's responsibility is going to be permitting the resource usage by that running process. So the kernel's job is to coordinate all these processes that are running, and it's going to coordinate how it's being able to use memory, how it's able to use the processor, and so forth. You may have heard the term page fault. What exactly is a page fault? A page fault is something that happens quite frequently on most systems. So in most servers, you won't have enough memory to run all of your running processes on physical RAM, on physical memory. So you use virtual memory. Well, when you have virtual memory, if a process goes to use virtual memory, or it goes to use memory at all for that matter, but when it goes to use virtual memory, if the virtual memory is not doesn't have a physical address mapped for that memory, the CPU has to go and fetch that data from the disk and has to pull it into physical memory. It's going to swap that with somebody else's data that's on that, in that physical memory. So that's how it allows all these running processes to be using memory, even though we don't have enough physical memory on the system. It really is something necessary in most modern systems. We're never going to have enough memory to run everything. And we want to have some flexibility if we need to launch more, services or processes, maybe even temporarily, that aren't going to have enough memory. This is common, especially in database servers. Databases use a tremendous amount of memory, so a lot of times you have to have a lot of virtual memory to support that. A page fault is when you go to get access to memory. It is not on physical memory, so it has to move that data from the swap or from the virtual memory into physical RAM. If you're doing this a lot, it will generally mean you have slower performance, but slower performance is better than no performance. So you can use certain Linux commands to take a look at the memory usage for processes. So an important part of managing these processes and their resource utilization is to look at how they're using memory. It's one of the most important things we do when we're trying to look at the performance of a process. So finally, here are some commands that you can use to monitor memory. So you have the free command, vmstat, pmap, and so forth. And there are some examples in your textbook, and we'll take a look at this in the lab environment.